All right. Chapter 3. Chapter 3 is one of these chapters where we keep learning something. We keep learning something. We know it has a lot to do with polynomials, mainly quadratics, but we keep getting these building blocks over and over and over in this chapter. And what we're going to see at the end is how we can put all of these together so that they will all mesh and everything comes together and makes sense why we did this thing and then we jumped over and did this thing and so forth. And the one that we're looking at today is going back to this division of polynomials. All right, let me yell at the dogs. They're supposed to be asleep. They're not asleep. Okay. And they're still barking. So we're going to take a look at the first thing today is, and you're going, yeah, there's all the technical talk. And it's okay to have technical talk. You know, we could put this in wherever we want. And at some point, there are those of you that are a STEM major and you need to see these things and understand them. And then there's some that not so much. They're taking college algebra. They're getting a bunch of concepts they need for whatever their major is. But today we're going to start by, yeah, it's up here, highlighted, long division. So again, we're working with polynomials and we're looking at dealing with long division. And again, this is a piece of a bigger puzzle. And hopefully that bigger puzzle makes sense when the time comes. But what we're saying is we can take a function, we're going to call it f of x, and then, excuse me, we're going to be able to say, you know, that function can be written as the product of two functions plus another function. Yeah, okay. No, here's what you kind of know what makes sense. I have a function f of x. I'm going to have something called the dividend, something called the divisor, and something called the remainder. Three terms that you've heard and you forget which one is which. The dividend, the divisor, the quotient. I know the remainder. That's definitely one that I have locked up in my brain and I understand it. Okay, so we're going to go back and we're going to take a look at a long division problem. And for my sanity, I think I better do this one in pencil instead of nice and bright red. And I'm going to see if you all can remember how to do this as I go through it the first time. And then I'm going to cut you loose on the next two and see what you come up with. All right, so terminology-wise, it says use long division. And I'm going to be doing something like the quotient and the remainder over the divisor, and hopefully those terms will make sense a little bit, and then we'll forget them by next week. But long division, 2x minus 5, that's the divisor. And this is going to go back to the same concepts you did when you were doing long division to start with just numbers. 2x cubed minus 11x squared plus 13x plus 15. I like it. I love it. I want some more. And hopefully as I'm talking, some of you are going, yeah, I remember how to do this, and I'm going to take off and start doing it myself. All right, these are in descending order. The leading term, descending order. And okay, so I'm going to start with this 2x. How many times does 2x divide into 2x cubed? Or what times 2x gives me 2x cubed? And the answer is not too bad. It's just in the x squared. I'm going to take x squared times both terms in this binomial, and I get 2x cubed minus 5x squared. Now, if you remember from long division, the next thing you would do is subtract. But in our world of polynomials, it's easier for us to think of subtraction as adding the opposites. Okay, so if I add the opposite, so I'm going to subtract but I'm going to help myself out by making it add the opposites. Okay, and that goes down to something like this. 4x cubed plus x minus negative x squared plus 3x. And if I was going to subtract that, if I was going to do the work, I'd say 4x cubed plus x squared minus 3x. Now I'd be better off combining like terms. So I put that intermediate step in there that if I'm going to subtract, it's the same as adding the opposite. Now I need my big eraser. The speed of light, it's gone. It's out of here. All right, with a little luck, some of you have kept going, and when I screw up, you'll be able to catch me. But anyhow, 2x cubed plus negative 2x cubed, negative 11 bananas plus positive 5 bananas is negative 6x squared plus 13x. You know, we only ever need to bring down the next term. I need a negative 6x, so I'm going to multiply by a negative 3x. That's going to give me my negative 6x squared plus 15x. How are we doing so far? All right. I know I now need to subtract. And again, subtracting, I'm going to say add the opposites. This plus this is going. And it looks like I'm going to get a negative 2x. Bring down the next term. What times 2x is negative 2x? Why, that would be 1 minus 1. So negative 2x plus 5. And I'm a creature of habit. I'm going to keep doing the same step because I want to make sure I get the right final remainder. Subtraction, same as adding the opposites, and I get a remainder of 10. So my answer here would be x squared minus 3x minus 1 plus the remainder over the divisor. And again, if you're forgetting something, let's go back to a good old-fashioned regular long division problem. Okay, so I have my answer. Gonna pause the video, let you all give number 2 a try and see what we have going on from there. Right, let's see what we have going on here. When I'm laying this out, and if I said, hey, the number 4003, you actually would put 4003. That's right. No, you would fill in those missing terms. Well, I'm going to do the same thing here. I'm going to fill in placeholders, and I'm going to put 0x cubed and 0x squared. And again, I'm hoping this is coming back to some of you. A lot of what goes on in college algebra, most folks have seen in possibly Algebra 1, maybe Algebra 2, depending on where they went. So let's see what we got. I got my red subtraction marker ready. I need to get rid of x to the 5th, so that's going to be x to the 4th, which gives me x to the 5th minus 3x to the 4th. Anybody have a remainder? I don't know if anybody got that far. They have a remainder and they're proud of it. No remainders? Okay. I'm going to subtract. Whoa. Whoa. I'm going to add the opposites. That's gone. This is also gone. This didn't exist, so I didn't have to worry about it, nor did this. So when I bring down, I'm bringing down a 12x minus 33. Well, this problem wasn't as intimidating as I thought. What times x is 12x? I need to do a plus 12. That's going to give me 12x minus 36. Again, creature of habit, subtraction is the same as adding the opposite. It's a little harder. And it looks like I get a remainder of 3. Final answer, x to the 4th plus 12 plus 3 over x minus 3. Now, as we move along, we're going to be hoping more and more that that remainder becomes 0, because that's what we like. All right, I'm going to pause again. Okay, let's see what we have. What times x squared gives me 2x cubed? Why, that's just going to be a 2x. 2x times that is 2x squared or cubed, minus 6x squared plus 8x. I'm going to subtract, which I know is the same as add the opposites. First term's gone. Looks like this is an 8x squared minus 24x. And I'm going to bring down the 32. Bring it down, Captain. What times x squared gives me 8x squared? It looks like a plus 8. 8x squared minus 24x plus 32. Subtract, same as adding the opposites. Opposite. 0, 0, 0, 0, 0. Nice. I have a remainder of a 0. Final answer, 2x plus 8. Can I get a thumbs up from somebody? And I got one from Nina. Nice. Nina, you're the only one that likes these. Okay. All right, so long division is just okay. I mean, that's, yeah, it's good. I can do long division. You know, I can do this one if I wanted to, and I'm going to, because I'm going to then show you another way to do this. X cubed minus 13x squared. You don't have to write this one down, but you can make sure I don't mess it up. X squared gives me x cubed minus 8x squared. I'm going to subtract, which is add the opposites. I now have negative 5x squared plus 46x. Again, let me know if I mess up. Negative 5x gives me negative 5x squared plus 40x. I'm going to subtract, which is add the opposite. I get 6x minus 99. This is going to become a plus 6. 6x minus 48. Subtract, add the opposites. And it looks like I get a remainder of 51. Okay? Oh no, what did I mess up? It is 49. Thank you. This is a 49. This is a 49. And negative 49 and positive 48 should be negative 1. Okay, is that better? Somebody say yes, that's better. X cubed minus 8x squared. Subtract is the same as adding the opposites. 5x squared plus 46x. I'm okay with that. Okay. All right. So now, there's something called synthetic division. And synthetic division is really nice because it can be really fast. Okay. Synthetic division works when my divisor is a binomial like this, x minus c. And in this case, I have x minus c. Okay, what is c in this case? C is going to equal 8. If I jump down here, I'm practicing this. What is c in this case? 3. What is c in this last one?
10.
No, it's not x
Minus 10.
Yeah, very good. It's a negative 10. Okay, it's going to fit the bill of x minus something. This would be x minus negative 10, which would be positive 10. So the first thing I want to do is say, okay, what is my c? My c is 8. So I'm going to write the 8. I'm going to now write the value of c in a box. Well, it's not really a box, but it's beside a box. Write the coefficients to the right of that. Okay, I'm going to come up here and I'm going to look at the coefficients. That's the number part. Yep. Coefficients are 1. That's good. Negative 13, 46, and negative 49. 1, negative 13, 46, and negative 49. Okay. Skip a line and draw a horizontal line. So we got all that. And next step is to bring down the leading coefficient. So I'm going to bring down the 1. So now I'm going to multiply. And my multiplier is my c. I'm going to take c times the 1. That's going to give me an 8. Now I'm going to add, then multiply. Add, then multiply. I'm going to add negative 5, then multiply. Here's my 8 times negative 5 is negative 40. I'm going to add those 2 to get a 6. I'm going to multiply 48 and finally add again. So I keep multiplying by my c to get that term. Whoa, check it out, dude. Guess what this last guy is on the right? That's my remainder. When I have a remainder, I write it over the divisor. The next term over happens to be my constant term. So I'm working from right to left here. My next term over is my x to the first power. And my next term over, which is 1, is my x to the second power. So I started remainder, constant, x squared. And if I had more, I'd keep writing them. And look what I have. The same answer as what was up here. X squared minus 5x plus 6 with a remainder of negative 1. Cool. Check out these numbers. 8, negative 40, 48. Boom, there they are. Check out these numbers. You know, well, we know those numbers because they're here for us. So somebody took this and revamped it into something much easier that I can do this thing called synthetic division. Awesome. Gonna pause it, give you a minute to try the next one. How about I put us in groups and you try 4 and 5? Yeah, let's do that. Okay, so I'm laying the first one out. We already said the C is 3. My 3 gets written outside of the L. Coefficients 1, negative 3, 0 for x cubed, 0 for x squared, 12, and negative 33. And as I'm doing this, I wonder if this is the same as the problem on the last page. Add 1 plus nothing is 1. Multiply 3, 0, 0, 0, 0, 0, 0, 12, 36, and 3. 3 is my remainder. 12 is the constant term. First power, x to the second, x to the third, and x to the fourth. Whew. When I can use this, again, this has to be x to the first power, 1x, just simple x right there. When I can use this, I can go pretty quick. Okay, number 5, tried to mess with you a little bit. This time the c is -10. I need coefficients to be in order. So it's 3, 25, -48, and 20. So I had to make sure I have my terms in the right order. Bring down the 3, then multiply, then add, then multiply, then add, then multiply, ooh, then add. Remainder is 0. Nice. That's a 2. -5x, 3x squared. And again, this is one of those, the more you practice these, you're like, I hope they're on the test because I can do these puppies. Any questions? Daniel, you got it? Good. There's another page. Oh my goodness, yes. Okay, so what do we have now? We have something called the remainder and the factor theorems. And you're going, oh boy. Oh boy. Well, let's see what's going on here. If I take a number like -1, that's my x value. So the way to think of this is -1 is the x value in this ordered pair. And if I ask you, what is the y value? You'd come over here and again, think of this as f of blah equals 5 blah to the 7th minus 3 times blah to the 5th plus 2 times blah squared minus 1. And then you come and say, okay, I'm going to put -1 in for x. So this is a -1, a -1, and a -1. And I'm going to be able to find the y value. All right. 5 times -1 to the 7th is -1. 3 times -1 to the 5th is -1. 2 times -1 squared is +1 minus 1. All right, that's going to be -5 plus 3 plus 2 minus 1. And if I put all of that together, I get the value -1. So for an x value of -1, my y value is -1. Okay. For an x value of -1, my y value is -1. Now, I'm going to take that and think, okay, so I have a graph at -1, I'm down at -1. What we just did was we wanted to see if this -1 was actually an x-intercept. And now I'm going to start to tie in this long division and synthetic division to what we're trying to do. We're trying to find numbers that give me a remainder of 0. Because if it's a remainder of 0, I would have the ordered pair something like 2, 0. Not sure what he's saying, but I'm going to hang in there for a minute. That means whatever my polynomial was, one of my factors was x minus 2. Okay, let's back up this bus just 1 minute. I'm going to get an equation, and I'm going to take the equation x squared minus 5x plus 4. Okay, and I'm going to say, all right, I want to pick some x values and some y values. X values I'm going to pick, I'm just going to make something up like -1 and 0 and 1, just for fun. So this is my function, f of x. We also know it's y equals. So far, so good. If I plug in -1, looks like I'm going to get 1 plus 5 plus 4, which is 9. If I plug in 0, I get 4. If I plug in +1, hey, I get 0. So I'm just trying to put a lot of this together here. If I do this, I'm saying, uh-oh, at 1, 0, I have that. At 0, 4, I have that. At negative, oh, so I have a graph that's coming down, and yeah, those two happen to be intercept. I know how I can find the other intercept, right? This guy actually factors. What does he factor into? X minus 4, x minus 1. So that means out here at 4, somewhere in here it turns and it's going to come back up. Okay, we've done all of this before. Okay, we factored and chaka. And we know that 1 was an intercept. Because if I set this equal to 0, I would factor and say 1 and 4, are my intercepts kind of deal. Okay. So now what I just did was I was able to factor this. But what if I couldn't factor it and I said, oh no, does x minus 4, does that divide into x squared minus 5x plus 4? Does this divide into that? Well, we know it does because it factors. And we'll go, oh, does it divide evenly into that? Is what we're looking for. We're looking to find factors of this. And I'm saying, wait a minute. I know if it divides evenly because my remainder would be 0, 1, -5, and 4. And if I plug it 1, 4, -1, -4, and 0, I'm going, yes, it is a 0. Okay, it divided evenly. Watch this. What if I plugged in -1? 1, -5, and 4. I'm trying to see if x plus 1 divides evenly into it. I get 1, -1, -6, 6, and 10. And you go, no, it didn't divide evenly. It had a remainder of 10. Guess what, sports fans? That remainder is also my y value. This remainder was my y value. So all of this is starting to come kind of together. Do you want me to do that again? Yes. Okay. Let's take a look at a quick graph, and I'm going to say f of x equals x squared minus 5x plus 6. All right. I would like to know, somebody give me an x value. Pick one. Pick a number. Any number. I have nothing up my sleeves.
1.
1. Okay. And if I said, okay, you give me the y value, you plug it in,
So
and what do you get when you plug 1 in for x?
plus 0.
2. I get a 2. This is a +1.
Oh,
And
yeah, 2. Yep.
yeah, 2. So I got that. I'm also going to say, does x minus 1 divide evenly into x squared minus 5x plus 6? Because I'd love to be able to know if x minus 1 is a factor. Well, if I did this, I'm going to do the synthetic again. I'm going to do this. 1, negative 5, and 6. 1 times 1 is 1. Negative 4 times is 2. X minus 1 is not a factor. I can't factor this. If this remainder was 0, it would be a factor. But again, you notice the remainder is also my y value. Remainder is y value. So it's kind of tying together here. Somebody else give me another number guess. 2. Somebody say 2.
2.
2. All right. If I say, okay, so meanwhile, back on my graph, I have the value 1, 2. And again, I know it's not an x-intercept. I didn't get a remainder of 0, but that's okay. 2. I want to know, again, what's the y value? But at the same time, I'm saying, is x minus 2 a factor of this? So I can find the y value by plugging 2 in here. That's one way to find the y value. And it looks like if I plug 2 in, I get I get 0, which means if I plug in C is 2 into here, 1, negative 5, and 6, 1, 2, negative 3, negative 6, 0. So my remainder here is the same as my y value. So if I wanted to quickly find out, you know, yeah, I got that. I found my x-intercept again because it factors into it, even though I couldn't straight out factor it. But when I plug 2 in, I got a y value of 0, which means x minus 2 is a factor. Then I'd be able to keep going from there to, oh yeah, x minus 3 is a factor. So the remainder is also the y value. No, shut the front door. It's windy and the screen door is blowing. That's quite a bit to take in, but this is what I want you to remember. The remainder is also the y value. I found this y value to be negative 1, which means if I would have plugged negative 1 into this, my remainder over here should be negative 1 because it's also the y value. Well, and a great example there, Miss Miller, the author of our book, because these are both the same number. But if I had done it that way, okay. Yeah. Use the remainder theorem to show that the square root of 5 is a 0 of the function. Yeah, I don't know that I want to do the square root of 5 into up here. 5, 0, 3, 0, 0, 2, negative. Oh boy. That might take a while to find out what the remainder is. But knowing that it's the y value, I can get ready and plug it in. I hope so. So in place of the x, I'm putting square root of 5 cubed minus 4 times the square root of 5 squared minus 5 times the square root of 5 plus 20. They're telling me that's a 0. So when I said, what is f of the square root of 5? They're saying this puppy needs to end up evaluating as 0. All right, I'm not real familiar with this, but I know to cube something, I can write it as square root of 5 times square root of 5 times square root of 5. Square root of 5 square, well, that's just 5. So that's times 5 minus 5 square root of 5 plus 20. Oh. Square root of 5 times square root of 5, I know that's 5. Minus 20. Minus 5 squared of 5 plus 20. Well, I'll be damned. It does equal 0. It does equal 0. So instead of doing all this synthetic division and ending up with a 0 out here, oh, goodness gracious, I was able to use the remainder theorem. And now I know there's an ordered pair, square root of 5, comma 0. Because the square root of 5 was the x value, 0 is my y value. And we all know square root of 5 is 2.35, blah, blah. Yeah, we all know that, right? Okay, talking to myself. Because I've been talking to myself. Oh, no, that's dancing with myself.
I could not get here why it says it's a 0 of fx. Well, what is the meaning of that 0 of fx?
The 0 here?
Yeah, no, in the sentence written here, use the remainder theorem to show the under root 5 is a 0 of fx. I did not understand this one.
Okay. It's a 0. So yes, good question. I like that. When I have a point on a graph,
Yes.
and it's like this, this point is going to have many names. Excellent question, actually.
Okay.
It's going to be an x-intercept,
yeah.
which we're familiar with. It's called a 0 as well, because my y value is 0.
It's 0. Okay.
Yeah, and we're going to see as we go, it's going to maybe have another name or two that we're going to call this. But it's an x-intercept is also a 0. Good catch. Right here. It's a 0 of that. Yes, thank you.
You're welcome.
Thank you. And again, here we're asking to show that it's a 0. Show that it divides evenly. Oh boy. Yeah. Yeah, okay. Let's see. I want to show. I'm going to put 8i in for x. Because my other choice would be to go 8i, 2, 1, 128, and 64. 2, 16, oh boy. Now I'm getting into working with complex numbers, and they're very complex for me. But I'm hoping that this guy down here becomes 0, and I'm saying, well, I don't have to do it that way. I can do it by plugging it in and seeing if the y value is a 0 like I did up above. And that's what I'm going to do. So f of 8i it's going to equal 2 times 8i cubed plus 8i squared plus 128 . Okay, sorry about the interruption. I know that you all just kept working, and you got 2 times, and then this became 8 cubed, which is what, 512? Something like that. 512 I cubed plus 64I squared plus 1024I plus 64. I cubed was the same as I squared times I, which is -1. So this actually becomes negative 1024I. I squared is -1 minus 64 plus 1024I plus 64. Yeah, and everything's going to clean up and it's going to in fact give me 0. I did that kind of quick because the multiplication is based on 2's and I can do that pretty quick. But it actually all works out that 8I is a 0. It's a root, except it doesn't exist because it's imaginary. Okay. All right. Factor theorem. Once again, this is trying to show that something's a factor, because if I plugged in, and this is now taking it another step. We mentioned this up above or on the piece of paper that I had before. I want to know if this is a factor. Okay. And if this is a factor, for example, if I said f of x equals x plus 4, x minus 1, that means it was a factor. It divided evenly. It divided evenly. So I'm going to go back to give me a c. If the c is -4, and I want to find out if it's going to divide evenly, my remainder over here is going to be 0. Or if I wanted to plug in f of -4, I could. So 2 ways of doing the same thing. This is going to be a factor. Now, I prefer this way, especially when we get into cubes. So I'm going to go back to my synthetic division of 6, 11, -60, and -32. Bring down the 6. A lot of people mess that part up. They try to multiply right away. You don't have to. Multiply by -4, -24. Multiply, then add. Then multiply, then add. I get -12, then multiply and add. And I've come up with the realization that, and I don't want this, that x plus 4 is not a factor of this. It does not divide evenly, unless I made some kind of mistake on there. And I did. Where's my mistake? Tell me where my mistake is. This is half the fun sometimes too. Find the mistake.
Is it 4 times -13?
What do you get?
Yeah, 4, 13, 52.
It's 52.
Yeah, which makes this -8, which makes this 32, and boom, I do get a 0. So yes, the answer to the question is yes, it is a factor. Its y value is 0. On my graph, I know that. This is -4, 1, 2, 3, 4. That is a 0. That is a y-intercept. Yay.
I have a question on this one again.
Yep.
So instead of doing this division, can we plug in this -4 in this equation and then try to find if it comes out to be 0?
You're exactly right.
Okay.
Yep, that's what this f of -4 is. So I have
Yes.
2 choices here. I can do either one.
Okay.
Yep. Good. Whew. Okay. So I know that this is a factor. Okay. I know that this is a factor. And it says factor this given that f of x minus 6 is a factor. All right, so here's what I'm going to do. I'm going to say 6, and I'm going to do this. 4, negative 24, negative 3, 18, negative 1, and 6. And I'm going to go to town. Four, 24, 0, 0, negative 3, negative 18, 0, 0, negative 1, negative 6, and 0. So this now wants me to factor 4x to the 5th minus 24x to the 4th minus 3x cubed plus 18x squared minus x plus 6. And I know that this factors into x minus 6 times, that was the remainder. The negative 1 was my constant, x to the first, negative 3, x to the second, x to the third, and 4, x to the fourth. So I factored it. I wrote it as a product. I divided x minus 6 into it. I used synthetic instead of long division. Had I done long division, up here would have been 4x to the fourth plus 3x squared minus 1. Blah, 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 blah. So if I multiply these two together, I get that giant polynomial. Huh. All right, so we're going to go in reverse on this last question. The last question, yes, the last question of the 15th class, which means we have 13 classes to go after this. Polynomial of degree 3, that means it's going to be a cubed that has zeros, that has the zeros 2, multiplicity of 2, and negative 5. Okay, no, wait, I got it. If it's a 0, that means it's a factor, and I have x minus 2. If it's a multiplicity 2, that means I'm going to write it twice. Finally, how would I write x minus negative 5? Well, I'm going to change that quickly into x plus 5. So now I have, here's the factors. What's the polynomial? Well, I'm going to multiply these guys together. I'm going to get x squared minus 4x plus 4. Oh, okay, I'm getting there. So instead of factoring down to here, and my zeros are 2, and you notice it's twice, and that's okay. And negative 5, there's a new term, multiplicity. Get to this point. Now I'm going to double distribute. I'm going to take x times everything over there. Then I'm going to take 5 times everything over there. X times x squared is x cubed minus 4x squared plus 4x, now the 5, plus 5x squared minus 20x plus 20. I have 2x squared terms, so I combine those. I have 2x to the first power terms, so I combine those. And I get my polynomial. X cubed plus x squared minus 16x plus 20. Huh. So if I factor this, I already know what it factors into. This is a polynomial of degree 3. Unfortunately, there's not another page. I could keep going, and I know your interest is piqued. You'd love to keep doing this. Maybe not so much. Some of you, hopefully you're liking what we're doing and you're getting it. But are there any questions? Are there any questions? If not, a quick reminder, hopefully you printed out your chapter 3 assignment sheet already so that you can start working on that. And you have it available to work on over the break, because next week we do not have class. Next week is spring break. So after Thursday, you get a week off of lectures. The better way to put it. You don't have anything due next week, but you have plenty of time to be working on some things to catch up. So if there are no questions, I will see you on Thursday. Have a good day.
Thank you. Have a
Bye,
good day.
everybody.